Hello, welcome to another Houdini quick tutorial, this time about UV mapping with proxy geometry. So I'm just gonna bring in a file that I've created in Maya, which is our high-res mesh for this tutorial. So I'm just gonna create a file node here, add a null to it to visualize the data flow. I'm gonna call it out Maya file Maya geo. And I'm going to rename my file to file_Maya geo, and I'm going to bring in the OBJ that I've saved from Maya, which is just kind of a car, motor, hood or something, doesn't matter really. So to visualize our UVs, I'm just going to lay down a UV quick shade here, and as you can see, the UVs are quite messed up. They really don't look nice, so we're gonna fix that with a UV project node. And it's set to planar projection by default. It's projecting down into the ZX plane. And as you can see, with planar mapping, we get quite a bit of stretching at the front here. And of course, we could fix that with UV mapping techniques, but yeah, let's fix it with geometry. So I'm gonna create a grid here. And I'm gonna create low-res geometry that roughly fits our high-res mesh. So I'm just gonna reduce the division of the grid here, and I'm just gonna quickly make it match our high-res geometry just by moving a few edges and vertices and by extruding the front edge. Doesn't really have to be accurate, it just has to follow the general flow of the surface, and yeah, it has to be low res so that we can manipulate it later on. And we're finished here, so I'm just gonna add a little transform here just to move it up and away from our high-res mesh just a little bit, so that we can see what we're doing. So having done that, I'm just gonna add another null again just to visualize the data flow for now. And I really don't want to see these guys up here because we don't really need them right now, so I'm gonna collapse that into a subnet. I'm gonna call it sub low res geo, and I'm gonna call our null out low res geo, and let me just quickly move it up here. And I'm gonna lock that. So what this does, it kind of stores the representation of the data flowing into the null within the node, so it doesn't have to recompute and cook all the upstream nodes. Now we're gonna use a ray node, and what the ray node does, it projects one mesh onto another, either using the normals of the first input or the minimum distance to the points on the second input. And as you can see, it projected our high-res mesh into the low-res mesh quite nicely. So the next thing that we gotta do is we gotta kind of planarize our high-res and low-res mesh to project UVs onto them. So we're gonna use a lattice for that, which takes the first input as the mesh to deform, and two secondary inputs, which is the mesh to deform by. So the second input kind of is the base mesh, and the third input is the deformed base mesh. So we have to change the lattice mode to points. And yeah, I'm just gonna edit the low-res geometry to flatten out our high-res mesh. So I'm just gonna quickly move a few points here to straighten out the low-res geo and the y-axis to make it planar for UV projection. And having done that, I'm just gonna switch back to perspective view. I'm just gonna move a few more edges around here just to make it will look a bit nicer later on, I think, maybe, don't know, we'll see. So as you can see, our lattice is actually not doing anything unless we change the radius here, and as you can see, it doesn't really work. as expected, and this is because the lattice is working on points. So we have to feed it more points, which means we have to subdivide our input meshes, and we're just going to do that quickly with a subdivide node set to open subdiv bilinear, and well, kind of increasing the subdivisions here. We have to input the subdivision into both the secondary and third input of the lattice, because they expect the same mesh with the same point count. And I don't want to drive two subdivide nodes here, so I'm just going to copy the def parameter. I'm going to paste it to our second subdivide node as a reference, and it's an absolute reference, and I could have chosen a relative reference. I'm going to change that by just typing // in the channel expression, and as you can see, it picked up the subdivision value of subdivide 1, and subdivide 2 is now using the same amount of subdivision. And let me just change that here to maybe 4, 5, 6 seems to be a bit high here, so I'm gonna choose 5. We're gonna change the function, the model of the lattice, by which it is interpolating between points, and changing the radius here. We can see that we kind of get a quite flat mesh. It's not exactly completely flat, so we're gonna change that with a little trick here, because we don't have to work super accurate for this. So I'm gonna add a transform node and 0 its y scale. However, what it does, it is using the world origin at 0, 0, 0 as the pivot point. So I'm just gonna type a little expression here, which is $CEX, CEY, and CEZ for the pivot point. And what this does, it takes the centroid of the polygons that we're feeding into the transform. So as you can see, we're now scaling around the midpoint of the polygon mesh feeding into the transform node, kind of leaving our mesh where it was before, which just is a bit nicer than having it move off. So taking a look at our UVs here, you can see it still has the same UV layout as the input mesh. So we're going to just change that by projecting planarly from the y-axis top down. And as you can see, the projection is working. Just taking a look at the UV viewport here and untemplating that. You can see that it's working. We have to change a few things here. We're gonna give it a uniform scale so that our texture pixels stay quadratic on the mesh, and I'm gonna change that to -10 because our numbers were flipped. So now that our little UV projection setup is working, we of course have to transfer the UVs back to our original mesh, and we're going to do that by creating a attribute copy node, which copies an attribute from one point on a input mesh to the same point on the second input mesh, and we're going to type UV as the attribute to copy, or we can choose texture UV in the drop down menu here. Doesn't matter really, so I'm just going to create another UV quick shade node so that we can take a look at our UVs. And as you can see, our setup works. However, we get a little bit of stretching on the curve here, and this is because we have to well, move our input meshes a little bit to kind of straighten it out. So I'm just gonna quickly go through our edges in the edit mesh, feeding into the third input of the lattice here, just to make the UV layout a bit more uniformly. I'm gonna create an edit on our low res geometry to maybe move the edges of our original low res geometry just a little bit. It's just a bit of trial and error here to get things working the way you want. However, it still feels a lot more natural than doing all those things in just 2D UV space. We've got a lot more freedom here. It's quite a bit of setup work, so you kind of only want to do that for the hard parts of a mesh. We could have fixed this part just in 2D space, but just as a concept you can see that this works, and I'm going to expand our low-res geo creation nodes here so that you can take a look at the whole node tree that we created. I'm going to just expand it here, move a few nodes so that you can take a look at our finished node layout. And yeah, I hope you guys enjoyed this. Have a great day.